calculating quantities with imprecise values. The number of significant figures should reflect the precision of the value of the input data to a calculation. Only a simple rule is required. For multiplication and division, the number of significant digits in the result should not exceed that of the least precise value upon which it depends. For an example, let's find the average speed. Let's say we travel a distance 27.3 meters and the time taken is 4.3 seconds. We have this to 3 significant figures, this to 2 significant figures. What is the answer? Distance divided by time is 6.3488372 meters a second. This is not a true answer. We're suggesting by writing this that we know it to 8 significant figures. It's not true. We can only be as accurate as the least precise value that we have here. The least precise one is 4.3 seconds, which is to 2 significant figures. So our answer can only be to 2 significant figures. 6.3 meters a second. Now, to determine what these maximum uncertainties are going to be, first of all, let's look at addition and subtraction of uncertainties. The rule is absolute uncertainties may be added. For multiplication, for division, and for looking at powers, percentage uncertainties may be added. For other functions like trig functions, the mean, the highest and the lowest possible values may be calculated to obtain the uncertainty range. If one uncertainty is much larger than the others, the approximate uncertainty in the calculated result may be taken as due to that quantity alone, in other words, the least uncertain value. So let's take this example. We have a pencil and a book, and we want to find out what is the distance from this part of the pencil to this part of the book. So we're basically adding the two values. Remember, addition and subtraction, the absolute uncertainties may be added. Now let's say we know the book length is 29 centimeters plus or minus 1 centimeter. The pencil length is 9 centimeters plus or minus 1 centimeter. What is going to be the sum of these two values? Well, the total length is going to be 29 plus 9, which is 38. However, there is an uncertainty, and the rule is we must add the absolute uncertainties. But let's look at what a real possible solution could be. If we take 9 centimeters plus 1, which is 10 centimeters, and 29 plus 1 is 30, we could end up with a feasible answer of 40 centimeters within the uncertainty. So it's going to be 38 plus 2. Or let's say we underestimate the value of the book length and the pencil length. So instead of being 9, it's going to be 8. Instead of being 29, it's going to be 28. Add them together, we have 36. So our average value will be 38, which goes up to 40 or goes down to 36. So it's 38 plus or minus 2. You don't need to do this calculation at the end. You just need to do is add the absolute uncertainty. So it's going to be 38 plus or minus 1 plus 1, which is 2 centimeters. When we do the subtraction, it's the same applies. We have to add the absolute uncertainties. The difference is going to be 29 minus 9 is 20. However, if we underestimate the length of the book and we overestimate the length of the pencil, we end up with a value 18. On the other hand, if we overestimate the value for the book and we underestimate that of the pencil, we end up with a value of 22. So our value will be 20 plus or minus 2. So here again, we're adding the absolute uncertainties. For multiplication, division and powers, we add the percentage uncertainties. So we have 200 meters plus or minus 5 meters. We have to convert that into a percentage uncertainty. We have the time taken. We have to change that into a percentage uncertainty and then add the percentage uncertainties. So first, convert the uncertainties, which are written as absolute at the moment, we must change it to percentage uncertainties. Then we add the percentages. Then we convert the final percentage uncertainty to an absolute uncertainty. And let's give an example of that. Let's find the area of a square. The length is 100 centimeters plus or minus 5%. We know that it's plus or minus 5 centimeters. We convert that into a percentage uncertainty. Let's calculate the area. It's going to be 100 times by 100. That's easily enough, which is 10,000 centimeters squared. The uncertainty is 5% on one side and 5% on the other side. So it's going to be 5 plus 5 is 10%. So our uncertainty will be the 5 plus 5 is 10%. Now we must find this 10% as a value of 10,000 and write it as an absolute uncertainty. So it's going to be 10,000 plus or minus 10%, which is equal to 10,000 plus or minus 1,000 centimeters squared, because 1,000 is 10% of 10,000. When you have powers, let's say find the volume and the uncertainty in R, it's the same as multiplying R by itself 3 times. R times R times R. So let's say we have a 10% uncertainty in R. It's going to be 10 plus 10 plus 10. It's going to be a 30% uncertainty in the volume of the sphere. And you can find the circular area with uncertainty or the volume with uncertainty.